Hey guys, I'm going to start this off. This is actually my second time starting this. I just got scared to bejesus because my landlord needed to be let in the apartment. Uh, there's a way to cut in through my apartment to get into his. But I digress. So let's say we have a problem. This problem right here, you'll notice, is very similar to problem 5, and I've already done some work on it. The big thing to realize, guys, that the force of gravity that acts on this block, if you just think about the block itself, gravity pulls it down. Tension's going to pull it back up. And then here we've got 3 ropes that come together and they're attached to 2 different surfaces. This one is apparently going perfectly horizontal, and that's at 0 degrees. This one's going perfectly vertical, that's 270 degrees, or 90 depending on how you're looking at it. And this one goes up at an angle. Now, what's this angle? Well, here's the thing. Mr. Lee gave you a problem just like this on your homework, is that this angle is going to be about 25 degrees, well, depending on whatever the problem is. In this case, it's 25 degrees. Now, you come down here and you look, you know that this angle right here is 25 degrees because it's opposite or alternate interior angles. Now, that means our actual theta, our theta 1, is going to be 155 because if you went all the way around you'd get to 180, but you need to go back 25 degrees. So that's something very important, that our theta 1 is 55 degrees. Now with these angles, what are we going to do? Well, at the end of each of these vectors, vectors can be expressed 2 ways, magnitude and direction, or by their points at the very end. And here we go, we have an x2, a y2, a x3, a y3, and an x1 and a y2, and these are the points that correspond to the ends of our vectors. And these points actually correspond also to the lengths of the vector components. So if you think about this, you could take this vector, this t1, and you could make a vector like this and a vector like this, and these 2 vectors, this would be your t1y, and this would be your t1x, and they would have lengths that correspond to these coordinates here. So the length of this t1x is the same as your x1. This length of this t1y is the same as your y1. Okay? But let's try to keep it clean. Here we go. We've got some stuff. We've got a lot of information here. We've got our angles. The important thing to realize is T3 is equal but opposite to our negative FG. And if we take all these coordinates, guys, the important thing to realize is that if we take all these coordinates in the x direction, say we added up x1 plus x2 plus x3, we could get, it would be 0. And if we added up y1, y1 plus y2 plus y3, it would be 0. So how do we get to that though, Mr. Shaw? Well, we use that formula that Mr. Lee gave us, and it's quite a handy formula. It is x1 equals the length of x1, or the length that corresponds to x1, which is t1 cos theta 1. Now notice, guys, lots of 1s in this, so it gets pretty easy to make sure that you're doing the right thing, because x2, well, what do you think it's going to equal to? t2 cos theta 2. Sorry, that doesn't look like a 2. We're stuck with it. Or are we? And x3 equals t3 cosine theta 3. And then y1 equals t1 sine theta 1, and then y2 equals t2 sine theta 2. Now notice, guys, I'm using a little different approach, but guys, I'm expressing these things a little differently, but we're going to get the same exact thing. Please don't get confused if my notation is getting annoying. I understand, but you can bear with it. You can do this. Okay, now we've got these formulas. All right. So, what are we going to do? Well, you need to plug in the values for these angles. So go back over here. Wherever you see theta 1, you plug in 155. Wherever you see theta 2, you plug in 0. And wherever you see theta 3, you plug in 270. So this is 155 degrees. This is, I think, 0 and 270. Okay, so once you do that, then you put them into your calculator. And what do you put in your calculator, guys? I really want to stress, you're not going to put a whole lot in your calculator. You just simply put this in your calculator, this in your calculator, this in your calculator, and the same thing over here. And what you're going to end up getting is you're going to take these values whatever you get for your x's, ones, and plug them into this formula. So you should get x1 equals something times t1. So I'm just going to put in some numbers. You should get like, and these are not right at all, 0.5 t1 plus, you should get something for this one. You should get like a 0.7. I'm just making things up. T2, and then you should get plus 0 t3 equals 0. And you should get another formula similar to this over here. And then, guys, you're going to have to do some algebraic creativity to solve for some answers. Solve for answers on one side, plug them into the other. Okay, good luck.